This would be probably last section for the DFM, Design for Manufacturability. And this time we're going to learn about how to do mold simulation. While it sounds quite challenging if you say, oh, are we running simulations on this class? But matter of fact, it's quite simple if you just use one of the feature on Fusion 360. So in Fusion, there is section called simulation where it has different types of simulations that you can use, such as like finite element analysis for static stress, or you can even do thermal simulation. While it's compared to other software that is specifically designed for this sort of simulation, it might be very basic. However, since we are only using it for class purposes, I think this is more than good enough to give a glance of how you can actually use simulations in order to improve the design for manufacturability. So among these all of the studies, you can actually select this injection molding simulation and then hit create study. So just like any other finite element analysis, usually we go from the user interface, usually go from left to right manner. So it sounds like there are too many choices to take, but you can actually slightly go from just like a new simulation study into left to right. So for example, if I click new simulation study, you can add more studies if you want. But since you're already inside here, now what we can select is click target body. And since we only have this keycap example as a target body, we can select this and say OK. And then now you have to set up the materials. When we click materials, you will see a list of materials that you can choose. And by default, I believe that it's set as PP, polypropylene. But you can change into different plastics such as ABS if you want. So you can search for ABS and choose this generic ABS. But let's use PP for now, polypropylene. And then this all has already like a recommended setting, such as like a mold surface temperature for 50 degrees Celsius and melt temperature for 220 degrees, or ejection temperature and so on. So we don't have to actually change that for now. And say select. So now we already set up the materials. Now what we have left is this injection location and aesthetic faces. So I'm going to explain one by one. Injection locations are, if you click this part, you'll see that there is one part that's already designated for, that looks like this in a yellow arrow that you see in the middle. So I think it's randomly selected as the gate location. Do you remember the gate location that we learned about in the injection molding? That's the part where the molten plastic actually pulls down in. And you don't have to actually use this. We can select different injection locations. We can actually choose multiple injection locations, but let's just choose one. And since we don't want to use this part, I can just click this injection location and then remove injection point. In this case, we will have only one injection location. And if you want to edit this location and then move the place, you can actually change the location as it is like this. And this actually affects a lot on how your part will print out, because this doesn't consider actually the design of the mold itself, because you're considering the mold is already closed and you're only filling in depending on the different locations. So this is how you actually choose the injection location, which might be the only factor that you can change the quality of the part in this manner outside the process settings, such as the temperature for like plastic, or how much time that you're going to set for the injection and cooling time. So you can probably choose this injection location. For example, if you have aesthetic faces, which is the part that the user will see outside, you might not want to put the gate location on this surface, because you will have a gate mark on the outside, but rather you want to hide it in the inside part, right? So I can click as OK. And you can also select aesthetic faces. And what it really means is that this won't affect on the simulation itself, but it actually gives a clue to the simulation model that this outside part matters because that's what people are going to see, and they are going to analyze based on what you select as aesthetic faces. So consider aesthetic faces are some part that the user or the user of this device or part will be able to see. Now we can select OK, and you will see that the color has changed into green. And you can consider, oh, this part won't be like the part that is not marked as green will be considered for the users that this one doesn't matter that much because it's already hidden. But compared to that, this outside part would matter to the users because this is the surface that we care the most. And process settings, while we already have like automatic settings such as the melt temperature and mold surface temperature as it is, we can also change the settings. We don't have to change the settings here, and you can actually do the pre-check, and you will see the sign that the study setup has all the information required, meaning that all of these settings that we just gave, such as target body, materials, boundary conditions, are all set, where the last part that we have is just to click solve, which is the good thing about this Fusion 360 is that they give out the educational license with the free of credits. So while it says like cloud credit 6, because we are using educational license, because we are only using it for class purposes, we don't really have to worry about the credit. And you can click solve study, which will take, from my experience, it took over 10 minutes. So once, for example, the simulation has been over, you will have not like this, you will have a finished results like this. So if you double click the results, you will see that the results as here. So this is probably the screen that you will see once you're done with the simulation. And you can probably see that I actually set up the location differently in this simulation just to see the difference. And you will see that it is saying that it's easy to fill, meaning that since this part is actually pretty small, it's a keycap, right? So since this part is quite small, it is easy to fill. However, if you click on different parts, such as visual defects, because I set up the study as this part to be considered as the aesthetic faces. So if I go to the results and then see the visual defect, you will see that it's throwing a lot of error message saying that, to reduce the sink mark, we probably remember the reason for like sink marks, right? If the part is too thick, then there's a chance for the sink marks, so you might want to reduce the wall thickness, or there's a chance that the injection molding location, such as gate location, might have caused some of the problem. So you might want to change the gate location based on what you want. And it's also saying that, there should be a weld line if you are trying to put gate location here. You remember the gate weld lines are, for example, the two melted plastic actually meets in one of the surfaces especially in the appearance surfaces that we aesthetic surfaces that we don't want. So you might want to reduce that. And those are all the error messages that you might want to check. You don't have to solve them all. However, it's just a suggestion that you can actually improve your mold design based on, or part design for injection molding. And also if you go to warpage, it's saying that there's a chance of, if I put the injection molding location here, and also if I design the part as it is, if it is injection molded, then there's a high chance that this might have a little bit of warping. So it might look quite scary. It really depends on the tolerancing. So if I say, the 0.065 millimeter is good enough for tolerancing, then this part is probably good to go. Whereas if I set the tolerance as 0.05, in that case, I will see many part as red color because it's all is exposed to some of the warpage, meaning that it's going to deflect once the injection molding is done. And one last cool feature that we have is you can actually simulate the molding process as it is. So if I click play, then you can see how step by step the molding will result So this is the injection process, and this is the packing and cooling part, where the last part will be ejection. And by doing this, you can actually simulate one by one on how the part is going to look like. So I can also go step by step on how it actually looks like and see where the visual defects might happen. So this is just to demonstrate. You can click finish result, or you can actually have the compiled report on the like a PDF that you have. It automatically generates like different views and information, such as the results on, for example, the like warpage or visual defects and so on. So this was the demonstration of how you can use mold simulation on Fusion 360. And as you might have just seen the features, while it looks a bit scary to apply this mold simulation in your design or in your project, however, you will see that it's quite basic. And since I believe that Fusion 360's mold simulation is very basic to be used for even for undergraduate students, so I really wish that you apply these to your project and see how it actually turns out. Don't worry about if your part design has like none of the error message that you see here, but rather just try to experience this and then see how your part could be improved further using this mold simulation. So that's it for the mold simulation tutorial.